Hello, welcome to episode 3. Today we'll be talking about the unified programming model that RX has. In particular, how it integrates with the rest of the world. And we'll see that today. So, again, what we're talking about is the first part, how the observables, how we represent asynchronous data streams. And so now, Bart mentioned in the first, I guess the 0th episode, about how observables actually are the unifying interface. And we'll see that in the code today. So this, in the center of this picture is like the happy nirvana. Actually, this is a wonderful slide that Bart did here.
Okay.
And so what it is it's a happy nirvana of like, where everything is great. And we talked about, in the last episode, we showed how observables are better than .NET events. But actually, there's already a whole bunch of existing code that uses .NET events, and a whole bunch of existing code that uses enumerables, and a lot of code that uses just functions and tasks and the asynchronous programming model. But all of these things need to communicate together. And what we want to do is bring them into a common world. And so we actually have bridging methods that actually convert to and from the observable world into .NET events, into tasks, and everything else. And that way you can actually, you can bring your tasks and your events together into a common programming model for asynchronous data streams. And that's like what the power of RX is. It gives us kind of the lingua franca to deal with asynchronous data streams. All right, so another thing we should note here is we're not replacing existing asynchrony, okay? So there's all these wonderful things like stream insight and tasks and all these great things. We want to have all those wonderful things, but what we have now is iObservable, which is the way we can talk with these, have these things communicate together. And it's all of them are just various forms of streams. And once we have that, we can have this unifying interface and then bring them together, then query them. So just like I said in the 0th episode, we're the glue that you can actually glue all these things together and compose them.
It's just like IEnumerable is the unifying sequence for a lot of data stores, like a SQL database and a memory database and XML documents.
Yep, for the synchronous data streams.
For the synchronous data streams, indeed.
Yes. So if this is the 0th one, I'm just going to say this, you introduced this as the 3rd.
I did? Oh, it's the 2nd then.
It's okay, that's fine.
Man.
You don't have to redo it.
Well, it depends if you're a VB programmer or a C# programmer. So I was trying to reach out to both of them.
Rock and roll. We can interact.
Okay, so unifying. So here we have a little text box. We're typing along with React. That's like the prefix of the string I'm typing. And each time I type, what I want to do is actually surface an event stream of strings, which is the current prefix. So I have the text changed event, and as it changes, for example, when I have the prefix React, I want to raise that event, and then off it goes to the server. And so we send this off as an asynchronous request. So there's an event going on here, and there's an asynchronous request here. So we have like 2 forms of kind of asynchronous data streams already. And so we send this off to the server, and then the server is going to respond back. And when it responds back, the response itself is the asynchronous part of the stream, and it comes back with a bunch of dictionary words that it's going to suggest to us. So at a high level, we have this event stream, and for each time the event fires, we want to go off and make a request to the server. And this is like the canonical dictionary suggest you have in like Ajax applications. And so we combine these 2 things together. Again, we convert them into the observable land, which is how we represent these things, and then we bind it back to the result.
So you're really composing 2 data sources here.
That's right. We're composing the 2 data sources together. And so that is like the beauty of RX, is we can bring together events and asynchronous programming and into one common model. All right, so let's have Bart show us what that means in code.
Okay. So this time, actually, because we're doing some UI programming, let's actually start from, say, a WinForms project. So let's create a new project here. Let's use Windows Forms and add a reference assembly to system.reactive again. So here we go. We'll add a reference to system reactive, and we'll see later in this episode that we also add a reference to some other assemblies that are helpers for Windows Forms, but let's actually talk about it separately. So what I want to do here is really react to text changes in the text box. So let's start by adding on the toolbox here just a single text box, like here. And just to emphasize that we're not really changing, or meaning to substitute all of the events, in the .NET framework, we'll actually bridge to the text changed event, but we'll actually use a form load event, a classic .NET event, to actually handle the load event of the form. We're not going to substitute that particular part with RX. So let's actually double click on the form, and here we go, we're actually in the load handler, the classic .NET event handler for the form load event. Now, what I can do with textbox1, of course, is I could go to the designer and I could do things like text changed and actually hook up an event handler to text changed. And if you take a look at this thing, it's not particularly useful. It actually tells you that the event has fired, that the text has changed, but there's no way to actually get to the text that has changed by simply looking at the event arguments. Because if you look at E, well, it's just a canonical event args base type that doesn't contain the text that has changed. So actually you already see that things are sort of breaking down a little bit here. So how can I basically import this text changed event, ideally as an iObservable of string, into Rx? So that's actually the main question, right? So let's take a look at how we can do that. So instead of doing plus equals, we want to do something like subscribe. But obviously you can't do that on .NET event, which is just some action or some delegate type. So instead we are going to do observable, and we'll use one of the bridges that lives on the observable class called fromEventPattern. So fromEventPattern allows you to import classic.NET events that have an object sender and some, derived type of event args as the event arguments coming in. So I'll actually use fromEventPattern here, and depending on the event you're actually bridging with, you can specify a generic parameter that specifies the event args type. So if you're importing, say, mouse move events, you typically have mouse event args. And if you want to get access to that data, you can actually pass in that event args. In this particular case, I don't really care about the event args because they're basically just, the top type, the less derived type of event args that exists on text changed. So there's not much useful information in there. So now let's actually pass in what I want to listen to, and you have a number of overloads here. You can either give us the target and the event name, but you can also give us over here an add event handler and a remove event handler delegate. So there are different options to do that. I will go for the reflection based one over here, where you actually pass in the object as well as the event name. So the event name is text changed. Oops, if I can spell this thing correctly, like this. So what's the result of actually importing this thing? If I assign this to var result, you will actually see that the type of this guy is an iObservable of event pattern of event args. So let's take a look at what's inside. If I do res.subscribe of E goes to, and I dot into E, you see two pieces here. You see the event args, which are not really that useful as we said before, and we have the sender, which is basically the system.object that represents the text box. So you haven't actually lost anything by going to the world of Rx. You actually still have exactly the same information available. But what you can do now is you can start composing, event streams here. So should we show, doing a simple query over this?
Sure.
Yep.
Yes.
So let's actually show how we can take this iObservable of event pattern into an iObservable of string, which is really the thing we care about. So the way you actually transform a stream of data in typical database applications is by using projection, right? You do a select based on the event stream. So can I do that over here as well? Well, the answer is yes. You can say something like from E in the events that come out of the system.
And what's the type of E there?
And the type of E will be, well, it will be one of those event patterns of event args, which is a totally, inferred type here based on the from event pattern that's based on event args. If I would do from event pattern for mouse moves and pass in mouse event args, I would see E to be an event pattern of mouse event args. So I could actually dot into event args and get the XY coordinates out of there. But in this particular case, event args doesn't convey any meaningful information, so I still need to put my finger on that information somehow. And there are different ways to do that, of course, which you would have done before with classic.NET events. Like one way would be to take the sender and actually cast it to a text box and get the text out of there. But once we do this whole composition once and for all, the thing we actually get back here, and actually I shouldn't use E here, because, well, E already exists over here. But once I do this, what I have back now is an iObservable string. So I've basically projected away the event args and the sender to something meaningful. And from this point on, I have an iObservable string, which I could pass into some other component, right? Like, because it's a first-class primitive, I could pass this to a constructor of some monitoring service, which you couldn't do with classic.NET events, because you couldn't put your finger on the event to begin with, and you couldn't transform the .NET event easily to some other kind of event. So now that I have this, I can do something like res.subscribe, and let's simply take the string and do something like, this.text equals s, just to show that this thing works. Let's press F5. And the thing we should see is, as I type, you see the title bar of this particular form changing. So now I've bridged this entire sequence into the world of Rx. I've used some query operators on top of that, and you see that I can actually write some event handler by simply using subscribe.
That's right. We'll see more powerful query operators in the next episode.
Yep.
So one question, it had from event pattern. I noticed there was a from event as well.
Yep,
so what's the
exactly.
difference between those two?
Okay, so from event pattern confirms to something which is rather soft, which is a design pattern guideline to have .NET events with an object sender and event RxE. But actually the CLR or C# or VB doesn't restrict you of having events that convey that particular pattern. So say that you have an event that's just based on action of int, or any delegate type, you can use from event to bridge with those.
That's right.
So like in the previous episode, we actually showed how to bridge with .NET events, or how to represent .NET events as subjects. There we used actually an action of int as an event. And so if you would like to import that guy, you could actually simply do observable from event pattern, without the pattern part in this case, and basically point to the .NET event and get just the ints out. And then you would see an iObservable of int coming out as opposed to an iObservable of event pattern of some event Rx type.
Great.
Yep.
So let's look at the challenge.
Yeah.
So the challenge for this episode is actually to use the bridging. Whoops, excuse me. Let's go over find the challenge. So to use the bridging operators to bridge to implement dictionary suggest. In particular, you'll have to you'll see here that you have to bridge. Let me bump up the font again. There's a text changed event that we need to have, and there's a suggestions asynchronous function that we need to have. And
so the event for the text change we already looked at briefly.
Yep.
The one for the asynchronous pattern is something you can actually go and explore.
Exactly.
Yep.
And so what you'll need to do is basically change this section right here and the rest of this line as well. And if you do it correctly, then the sample should then work. And of course, feel free to improve the code as well. Have fun and post your code online.
Thank you.
That's a wrap.